don't want to consume your lot of time. So let me share my screen. Can you see my screen?
Yes, Jackie.
Okay, good. So guys, welcome to Surat MuleSoft Meetup 42. And the topic for today's meetup is Runtime Fabric Manager on self-managed Kubernetes and how it is differ from Runtime Fabric on bare metal and the virtual machines. So this is the topic. So I will start with a safe harbor statement. Both the speaker and host are organizing this meetup in the individual capacity only, and we are not representing any organization or any companies here. And this presentation is strictly for education or learning purpose. And organization doesn't hold or presenter doesn't hold any responsibility that same solution will work for your requirement. And the presentation is not meant for any promotional activities. Some housekeeping activities. The recording of this meetup will be uploaded to event page. Generally it doesn't take 24 hours. It will be uploaded within 5 6 hours, but sometime it may go up to 24 hours. You can ask a question at any time. Just try to make the session interactive, and try to make session more and more interactive. And later, I will just suggest everyone to provide the feedback for the session. You will going to receive a email, and you just with the some link, and you can click on that link and you can provide a feedback, and this will help us to improve in the future meetups. Okay, I will not give my introduction. So Nitish, you want to give an introduction?
I'm also good, Jackie. Thank you.
Yeah,
Just one thing. Sorry to interrupt, Jackie. If
yeah.
anyone has having any personal concerns regarding the topic, or they can connect with Jackie and me after the meetup as well, because all are in indulge in meetups, so it takes a lot of time. Thank you.
Thanks, Nitish. So speaker again. So let me quickly go to agenda. So we will discuss. We will have a we already had a introduction. We will discuss about what is Elastic Kubernetes service and its architecture. What is Runtime Fabric Manager and its architecture. We will discuss about some benefits. We will discuss about ingress controller, last mile security, and the persistent gateway. Then we will discuss about a customer shared responsibility model. We will discuss about CPU busting, and there are many more things we will discuss about in this particular session. The first, let me start with what is containerization. It is very important. Before we move to the EKS RTF, we need to understand what is containerization basically, right? So basically, as you know, tools we use for the containerization, it is Docker, right? And Docker is an open platform for developing and deploying, or for developing, deploying, or shipping, or running your application basically. So basically you can deploy your application as a container, and you can run that application in the via Docker engine basically. The one of the main advantage with Docker, like each application can run yeah, in the container in the isolation mode basically. So basically each container running in the Docker, they are isolated with the other container basically. Like one container shut down, it will not impact the other container, right? So that is one of the advantage which we get from the containerization. So apart from that, there are many other advantages. One of the main advantage, like you can have a multiple containers. So let's consider I have a big Docker engine. In that Docker engine I have a 4 or 5 container. So one MuleSoft application, one container is running Node.js application, one container is running some XYZ technology application. So with Docker, so what you can achieve, like you can run within the same Docker, you can run the application written in the different technology, right? So that is one of the advantage of the containerization. So here, if you see a small diagram, a virtual machine versus a container. So I like what happens. You have a big bare metal server, and like you want to create a multiple virtual machine. So what you create, you set up one hypervisor between on the top of your physical machine. Then you can create a multiple virtual machine on that physical server. So why we are doing that? So your physical high amount of compute resources, like it have a terabytes or petabytes of hard disk, even it have a 100 GB or 200 GB of RAM basically, right? So to make the proper use of your bare metal or physical server, what you do, you divide that physical server into multiple machine using this hypervisor layer, and you can deploy whatever application you want and on that virtual machine, and all the dependency required for running that application, right? So on VM1 you have deployed F1, on VM2 you have deployed F2, VM3 you deploy the F3. So here we are achieving isolation at a virtual machine level, right? Apart from that, one of the disadvantage with this particular approach, you need to install a guest operating system also on each and every VM, and on physical server you will be having the host operating system, right? With container you can achieve isolation at a container level instead of virtual machine. So you can have a like physical machine or virtual machine. So it's like let's consider you have one virtual machine VM1, and you can deploy a Docker engine on that VM1, and on VM1 you can, on that particular Docker engine, you can deploy multiple containers. So let's consider I have a big physical server, or I have a virtual machine. On the top of virtual machine I will have a host operating system, right? On that host operating system I will just install a Docker engine, and then I can spin up a multiple container, right? So you, in one container you have application 1 and it's all dependency, in other container you have application 2 and it's all dependency, container 3 you have application 3 and all its dependency. Here you don't require a separate operating system for running each and every application. So you are achieving isolation or virtualization using a Docker engine. In case of virtual machine, or in case of like this particular first approach, you are achieving the virtualization using the hypervisor layer basically. So hypervisor is kind of hardware or software that you need to install on the top of physical machine, that can through which you can create a multiple virtual machine. And like in other approach, you are achieving the virtualization Docker engine. So let me explain few more case. So basically, so virtualization versus containerization. So you have a bare metal server. So you have a like a physical server on the top of that operating system, and you can deploy a multiple application F1, F2, F3. In this, we don't having any isolation, right? So you are deploying all your application on the same physical server, or on same bare metal server, right? Like in case something goes wrong with the physical server or bare metal server, all your application will stop working. In like then later we have come up with some option called virtualize, where like we can achieve the isolation level isolation using a virtual machine. So basically you have like a big physical server. On the top of physical server you have a host operating system. Now you are creating multiple virtual machine using hypervisor layer, and you can run whatever application you want. If you want to run more than one or more application, you can do that. And like let's consider I have a two virtual machine, and virtual machine one, F1 and F2 is running, having the guest operating system. On virtual machine 2, F3 is running. Here we are achieving the isolation using the virtual machine. Then come a containerize. So as I discussed, here we have a one virtual machine or physical server. Then we have a host operating system. We have a Docker engine. Then we have a multiple container. Each container is running one or more application. It depends like what is your. Here we are achieving the isolation at a container level. Then comes to other approach, where like you have a big physical server, then host operating system, then you have a hypervisor layer, then we have a virtual machine, and each virtual machine have a container engine basically. And we are running the multiple application in each virtual machine, which having the container engine. So this is where like you are in this particular approach, you are doing the virtualization as well as containerization. So both approach you are doing. So these are the four uh, way which we can use to run your application. The best I feel, it's a last one is the better one. So generally, like instead of using the big physical machine, you just set up the Docker engine on that big physical machine. So you can do what you can do, you can have a multiple virtual machine, and you can host the Docker engine on that particular virtual machine, and you can run the containerized application, right? So container is the standard unit of software that package up code and all its dependency, so that application run quickly reliability from one computing environment to other, and it package the code and its dependencies together. So generally what we do, so like we create a Docker file with each application, and in that Docker file we'll define all the dependency which we required, right? And it will like whenever we will try to deploy the application on the container or on the Docker engine basically, it will automatically pull all the dependencies and everything from the Docker hub basically, right? So you don't like, now let's consider if I want to move that application to other Docker contain engine or something like that. So you don't have to do any changes. You don't want to take care of any prerequisite. You don't have to go physically there and have to install all the prerequisite like web servers and all those things. You just have to define in your Docker file, right? And when you will run, when you will deploy the application, it will automatically pull all the dependency from the Docker registry or your private registry, and it will set up automatically. You don't have to do anything. Any question on this? Any question?
No,
I hope
Jackie, we can. Yeah,
I hope I've cleared this concept.
yeah.
Okay. The next, I will come to a MuleSoft deployment model. So MuleSoft has various deployment options basically. One is customer hosted Mule runtime. So it's a completely on-premise. You can run your Mule runtime on your on-premise. So your data plane can be in your on-premise. Your control plane can be on the anypoint platform. So it is not necessary like you need to set up the control plane always. Some organization might be having the restriction, the data should not go out of their network. So in that case, you can just set up a mule runtime on your on premise. You can keep your data plane there itself. Then cloud up, so everybody is aware of that. Cloud up, it's nothing, it's ipass. Then we come to runtime fabric manager. So runtime fabric managers can be set up on the virtual machine. That virtual machine can be located anywhere, like it can be located on any cloud provider environment. It can be on your on premise, or it can be a bare metal server also. And recently MuleSoft has introduced a self-managed runtime fabric manager, so that can be set up on EKS, AKS, and GKE. So AKS stand for Elastic Kubernetes Service, AKS stand for Azure Kubernetes Service, GKE stand up for Google Kubernetes Engine. Right. So these are the various deployment model. Apart from that, there is a PC and PCF also. So I will not going to discuss anything about that. So right. So these are the some deployment option. Any question on this deployment options? No.
So, Jackie, one question here. Shivam is speaking.
Hmm.
Uh, for example, self-managed. Can you just bring up the slide? Yeah,
Yeah.
self-managed runtime fabric manager. Uh, the control plane will be we can also deploy here, or we can use the anypoint platforms one.
See, for runtime fabric, your control plane must be always in your anypoint platform. That's a
Okay.
prerequisite. Without control plane, you cannot set up a runtime fabric manager. It always require a control plane. So, like for customer hosted Mule runtime, it's fine. Like if you don't have a control plane, even then also you can like run your Mule application. With runtime fabric manager, like it is always necessary to have a control plane in your anypoint platform. Let it be, doesn't matter where you are deploying on virtual machine or bare metal server, even you are deploying on EKS or GKE.
Okay. Thank you.
So let me start with what is a EKS. So EKS is nothing, it's an elastic Kubernetes service. It's a fully managed AWS service that makes your Kubernetes that runs your Kubernetes on AWS without requiring the user to maintain their own Kubernetes in the control plane. It is the AWS service to run, manage, scale, or deploy the containerized application in the Kubernetes. So basically, like EKS, it's completely a managed service. It's a fully managed service provided by AWS, which run manage your container application. So Kubernetes automatically scale up whenever it required to add some additional nodes, or like whenever it required to scale the computing resources, it does automatically. You don't have to do anything. So EKS have its own control plane basically. Like when it come to EKS, right, when it come to EKS, the control plane will be managed by AWS. The data plane will be managed by the customer basically, right? So in EKS, the control plane automatically scale up. So whenever like you don't have to say I want this many nodes, I want an X number of nodes. You don't have to tell anything. It will be completely managed by AWS. That you have to define. So what kind of EC2 instance you require, what kind of require, what kind of operating system you require, that you have to define when it comes to the worker node. So how how it EKS work, Kubernetes work, it have a control plane, then it have its like a data plane. The control plane is fully managed by AWS. You don't have to do anything in the control plane, like you don't have to take care of VPCs and all those things in the control plane. It will be completely taken care by like AWS. Then when it comes to worker node, so EKS node, so you need to define everything, like you need to define your own VPC in AWS. You need to define your own subnets in the AWS. Like you need to define EC2 instance, like what is the size of EC2 instance you require, what is the computing resources you want. So those kind of things you need to define, and how many nodes you require. Okay, but it support auto scaling. Like you can definitely put all this node into the auto scaling good group basically, and like in case of any worker node or worker node is busy, so it will add a more and more worker node depending on what auto scaling policies you have defined. In EKS architecture, a Kubernetes control plane is managed by EKS, as I mentioned, that is running in the EKS managed VPC, which I just told you. So it generally, when you set up EKS, so you just have to provide the worker node detail. So control plane will be automatically set up, like for you, so you don't have to worry about that part. EKS automatically manage the scalability and durability of the Kubernetes control plane nodes, and it automatically replace the unhealthy node. So in case if some nodes are unhealthy in control plane, like so that will be automatically replaced. Like you don't have to worry about those things. So you don't have to worry about the control plane, right? So I will tell you, so there is EKS will have its own control plane and database plane. Once we set up the RTF on the top of EKS, so RTF will have its own control plane and the data plane. We will going to discuss that part. So this is my EKS architecture. So before, like have you understand what is EKS, right? Any question on that? Like it's very important, you should know the EKS. Any question? Vijay, can you speak up, like instead of writing? Vijay, this is too early to ask this question because we haven't gone there yet, right? So let me come there, like so you will going to learn. Like this is just we have gone through what is EKS. So this is a typical EKS architecture.
Sure, Jitendra. I will take up the question later.
Yeah. Okay, so this is my EKS architecture. Before setting up runtime fabric manager, it is important your EKS architecture. You need to define your EKS architecture. For defining the EKS architecture, you require to set up a various AWS component, right? So let me start. First, let me ask one question. What is a net gateway? Anybody is aware of that? First, I will explain like what are those components. What is net gateway? I will explain. The first thing, what is VPC? As everybody is aware, like what is VPC? VPC stand for virtual private cloud. So you are creating an isolated network, a isolated space within the AWS, and each VPC have some CIDR block, which is a classless interdynamic routing. So you need to define the then you divide that VPC into the multiple small networks. So that is known as a subnets basically, right? So within VPC, you can have a like a small network. Let me show you how we can do that. So let's consider this is my CIDR block of VPC, which is 10 dot 0 dot 1 dot 0, or I will simply say, yeah, I will say 1 dot 0 slash, I will say 22. Right now, or I will say 20. Right now, I have to define a subnet within that. So I will define subnet 1, which is 10 dot 0 dot 1 1 dot 0 slash 24, which will get 255 IP addresses. Sorry, 256. Then I will define a subnet 2. So I'm dividing my VPC into multiple subnets 0 dot 2 dot 0 slash 24. Then I am having subnet 3, which is 10 dot 0 dot 3 dot 0 slash 24. Okay, so this what I've done, this is my bigger network. I have divided into the smaller network, which is like subnet 1, subnet 2, subnet 3. The subnet can be private, subnet can be public, subnet can be protected, right? So we will going to discuss. Like let me share my screen again. So here I can see, like here you can see I have a VPC. I have divided that VPC into the smaller network, that is the subnet. I have a public subnet, I have a firewall subnet, I have a private subnet, right? And I have spin up that particular subnet across the multiple availability zone. So availability zone is nothing, it's a data center. So like I have a like within the one region basically. So in so currently I've selected one of the region in AWS which having the three data center, AJ1, AJ2, AJ3, right? And I will spin up those subnet across the multiple data center to ensure the high availability. Like in case one of the availability zone goes down, you have a still two availability zone who can take care of your request basically, right? So that is the availability zone. So whenever you are configuring your subnet, you can define that subnet into the multiple availability zone. Okay, so this is clear, right? So now we have a VPC, then we have a multiple availability zone. So I've created some small network, that is public the firewall subnet that has been multiple for the high availability. So here we are talking about the like EKS cluster basically. This is my EKS cluster, and here we are talking about that EKS worker node basically. We are going to set up EKS worker node now. So now what we are doing, like we have to, like when we are setting up the EKS, we need to say like what EC2 instance you want. So that EC2 instance is nothing, it's a virtual machine. You will define the size of your virtual machine, and you will spin up those EC2 instance into your private subnet. So basically, why private subnet? Because you don't want like to give the access for your EKS node outside the world basically. So he will deploy those EKS node or that those EC2 instance into the private subnet basically, right? Then like you, this is clear, right? So we have a worker node running in the private subnet. So those worker node node will be directly accessible within the outside the world. Then each subnet have a route table basically, route table, right? So if you see each subnet is associated with one route table. So what those route tables? So with that route table, you can define how the traffic from private subnet can be sent outside and can be come inside. So those you define into your route table. So route table is nothing. So the way how traffic can be route from or to the private to subnet basically. I will not say private subnet, to the subnet basically. He right, is this clear? So here the first thing is VPC CID local. So in this case what does this mean? So like it means like I can access any IP addresses from this particular VPC. The same thing has been defined on all the route tables. Then I come 0.0./0 firewall agent. So basically this private subnet can send the traffic to the firewall subnet. So that is the route table I have defined basically, right? So there are two route entry. One is VPC CID. So VPC CID are like, so send the traffic to any IP address for that VPC CID. Then here I'm saying firewall EJ1. This private subnet can send the traffic to the firewall subnet. Okay, and like now come to firewall subnet. So basically, what is a firewall subnet? Before that, you need to understand two things. So one is internet gateway, right? So first we discuss about this public subnet. Like what does public subnet mean? So whatever like public subnet means like your it can reach to internet and it can accept the traffic from the internet basically. So that is your public subnet. So like how you make the subnet public? So you associate this internet gateway with your subnet, then it become a public subnet basically. Whenever you associate it internet gateway with any subnet, it become a public subnet. By default the subnet is private. Once you associated internet gateway with your subnet, it become a public subnet. Now what is a net gateway? So net gateway basically whenever private subnet has to send the traffic outside. So with net gateway, a private subnet can send the traffic outside, but with net gateway, the traffic cannot come inside towards the private subnet. So for that, we create a net gateway in the public subnet. So whenever private subnet want to communicate with any SaaS application, any application which is outside our data center, they can use the net gateway, right? So net gateway only enable egress traffic. Yeah, but once the egress traffic send outside to the net gateway, we can get the response. Like we can like whenever it's a synchronous communication, it will work. But whenever when somebody try to connect this private subnet via net gateway, it is not possible, right? Is this clear? Difference between net gateway and internet gateway. Any question on
Uh,
this?
So
yeah,
one
we can
question,
hear you.
Yeah.
Yeah, go ahead. Yeah.
So one question, Jackie. So
Yeah.
NAT gateway is basically it acts as a bridge between your private network and public network, correct?
See, you are correct. Basically, let's consider I have a private subnet, right?
Mm-hmm.
So
Mm-hmm.
I have in private subnet, I have deployed my EKS node. So what will happen
Okay.
whenever you will deploy the MuleSoft application? It will get deployed on those EKS node, right?
Correct.
Is I am correct? Now,
Yeah, that's perfect. Yeah.
yeah. So now those application which is deployed on EKS node has to communicate to the outside world basically, to outside your
Correct.
data center. So
Mm-hmm.
by default, there's a no traffic allow from the private subnet, right?
Mm-hmm.
So now
Mm-hmm.
what we can do, we can have a net gateway basically,
Mm-hmm.
right? So through net gateway, a EKS node can communicate with outside world, but outside world cannot communicate with the EKS node via net gateway.
Correct. So for communicating with the outside gateway, I mean, we have internet gateway. Again, that is
See,
that basically
why we want internet gateway? Because we have to always deploy a net gateway in the public subnet. To make the
correct,
subnet public, you need to associate internet gateway with that particular subnet, then it become a public subnet.
correct.
So,
Yes,
Jackie, what I understand, so net gateway, using net gateway, we can do outbound calls.
Yeah.
But uh,
Once the see, I will tell you, you can send the egress traffic.
yeah,
Ingress
egress
traffic
traffic.
is not allowed. But if it's a synchronous, let you consider you are calling some web service which is
Hmm,
outside the your data center,
correct.
right? it,
Hmm,
it will accept the response from that, it will allow that response because
correct.
your channel has been created,
Correct.
right?
Yeah.
It will allow that. But
So
if somebody was trying to directly call your private subnet application running in the private subnet, it's not possible.
not
that will
possible.
be
So
possible.
outbound
Yeah,
is fine, but for example, means it's EKS, which is like your microservice architecture. I have service A, service B, service C. So in my EKS node, I deployed service A, so I can definitely call service B. But somebody calls my service, so that inbound call, how we can?
I will come. Let's wait. Let me finish. You will come to know everything. Like, don't worry.
Okay,
Okay.
okay,
So
okay.
it's there. It's there. It will come. Now, why? Now your question must be why we say. I will ask that question. Why we are setting up the firewall subnet?
Firewall subnet, yes, that's correct.
What is the reason for that? Why private subnet is not directly connecting to this net gateway? Why it's connecting via firewall subnet? Anybody can answer this question. See, if you see,
Maybe we
just a
can,
minute.
yeah.
Yeah, yeah. Steven, go on.
Just a guess. Firewall, here we can do some type of whitelisting or some type of policy where we can implement port opening kind of activity we can do here in the firewall. This is my guess.
Okay, I will come. So here, if you see in the route table, so private, see, sometime some organization doesn't create a firewall endpoint, basically firewall subnet, right? But
Hmm.
my requirement is that what is happening, like if I am sending, if see, I have a EKS node in the private subnet, right? If I am directly connecting to net gateway, this EKS node can send the traffic outside to any URLs, basically, right? Any URLs. But as per organization policy, like EKS node should not send to traffic to any public URL. Let's consider you are a developer, correct? You are a developer and and you are doing some testing and you are connecting to some public URL which which your organization should not do that, right? And you are deploying the application for testing purpose, right? But you don't want to do. If you are directly connecting to the net gateway, all the egress traffic is enabled, right? Why we are putting the firewall subnet here? Because EKS node, if EKS node want to connect with some XYZ service, that XYZ service must be vitally stayed in firewall subnet, and then firewall subnet will connect to net gateway. If let's consider I'm connecting to XYZ node, XYZ web service from EKS node, that XYZ web service must be vitally stayed or must be allowed on this firewall subnet. So we have something called firewall endpoint. If that is allowed, then traffic will be sent to the net gateway. From net gateway, the traffic will go to the outside world. Let me
right.
explain more in better way. So let's consider I have a www example.com, right? And I want to connect this www.example.com to the from private subnet, right? www.example.com, I want to connect from the private subnet. So for that, what we will do, we will use the net gateway,
Correct.
correct? So
Yep.
this net gateway is in my public subnet.
Mm-hmm.
Let me maximize it. So private subnet will connect to this www.example.com, which is outside your data center using net gateway public subnet. In future, www.demo.com. So I want to I don't want to connect with this URL, basically, as per your organization policy, right? So by default, what will happen, I can when private subnet will connect to this particular URL, it will connect, right? Because net gateway will allow any egress traffic for now, correct? We don't have any validation. We are not checking what kind of external URL is whitelisted or what kind of external URL is allowed, basically. We don't have that rule. So for that, we are come up with other concept. So let me copy this two thing. So we have set up. Somebody doesn't set up a firewall subnet, but it's not firewall subnet is the private subnet will first call firewall subnet. Okay, and the firewall subnet will check whether www.example.com is allowed. If it is allowed, it will go to net gateway. From net gateway, it will go to www.example.com. Now I will come here, firewall subnet, right?
Jackie, one
And
one small question
let
over
me
here.
let me finish this. Let me finish
Okay, okay,
this.
sure.
Uh, okay, now I want like I don't want to connect to this demo www.demo.com, and my www.demo.com is not whitelisted in the firewall subnet, so it will drop the request at a firewall subnet itself, right? And for firewall subnet, like we have something called firewall endpoints. So within the firewall subnet we set up firewall endpoint. In that firewall endpoint, like we can set up some kind of domain name rules, and like you can set up some IP whitelisting and like some port whitelisting. Those kind of things can be set up here. Is this clear? Like why we are setting up the firewall subnet?
Yes, Jackie.
Yeah, Jackie. It basically you are writing some rules to allow traffic or stop the traffic.
Yeah,
That is
because
what your
like
firewall subnet is for.
yeah, and also firewall subnet will also check like what is the ingress traffic is coming basically, right? So those kind of
Correct.
things. So basically
Correct.
like I can like those kind of rules can be set up here, like so that is very important.
Hmm.
You are blocking or you are allowing the traffic using the firewall subnet. So if I'm not using the firewall subnet, this particular like application running on the private subnet can send the traffic to any SaaS based application, right? So you are
Correct.
doing some kind of restriction and a blocking.
Hmm.
Jitendra, I have a query here.
Yeah.
So as of now, there are three subnets, right? Where your EK is lying, and as well as your firewall, as well as your NAT gateway. So all these three subnets are falling under the same network.
Yeah, it's the same VPC. You can see that it's the same VPC, right?
Okay. So if that is the case, what about the internet gateway? Is it outside your VPC or is it part of your
Hmm.
VPC?
See, internet gateway will be always part of the VPC, okay? But you have to do the association with the subnet, right? Doesn't matter if you are setting up your internet gateway in the VPC, right? It doesn't mean like all your subnet will become public. Once you like set up the internet gateway, then you have to set up the route tables also, and you have to associate that internet gateway to the public subnet. Then it only become a public subnet. So let's consider if I'm associate this internet gateway with this private subnet, this private subnet will become a public subnet.
So, Jiten, if you go back to the previous notepad,
Mhm.
uh,
Yeah.
so in this scenario, we would be enabling internet gateway on the net gateway, right? We will not enabling it on private
Uh,
subnet.
yeah, it's like because we are setting up net gateway in the public subnet,
Mm-hmm.
right? That is the rule because like
Okay,
the let consider, let take a simple example. In which subnet the internet is available?
public.
Public. Now I want to send the traffic outside, so I can
Mm-hmm.
go through the public subnet. That's why I'm setting up the public subnet and net gateway in the
Okay,
public subnet, so I can send the traffic outside because internet is allowed on the public subnet, right?
okay, okay. Understood.
Is this answer your question?
Yes, it does. Yes. Thank you.
Thanks. Yeah. Now I will explain all these route tables now.
Okay,
So
one
let
one more question here. So instead of having this entire firewall subnet, can't we just have a security group around the DKS node and allow that security group through that net
can you
route table?
can you tell me, can I define the domain in the security group? No, I cannot, right? www.example.com, can I define that into the domain www.example.com in the security group? I cannot do that.
You need an
The
IP.
No, I don't like I see IP. Let's consider there are website whose IP is dynamic, that those keep on changing. Then how many times you go and allow the IP addresses?
Okay, okay. Mhm. Got it.
Got it, right?
Yeah.
You have a mobile application, right? And you have some website whose IP keep on changing dynamically, like right? I'm right? So you have some SaaS application, SaaS based product. Those IP keep on changing basically. So how many time you go and whitelist your IP, right? Instead of that, why don't you whitelist the domain?
Hmm. Okay.
When you say whitelist
That
the
is
domain, are you saying the IP ranges of the domain?
no. You simply go and just whitelist that domain www.example.com, whatever. Okay, you can always whitelist the IP ranges also. Okay, that is also possible, but For website, you will not have single IP, right? Or you have a two IPs, not more
For
than that.
example,
If
if you call Google, right? Google IP keeps on changing. It's a
yeah,
dynamic.
yeah. So that's why you cannot allow the IP addresses on the firewall, right? You have an option to allow the IP addresses, right? But here it's better to allow the domain, correct? Domain will not change,
Got
but
it,
your
Jaggi.
IP, the underlying IP can change,
Yes.
right? Is this answer your question?
Sure, sure.
Yeah. Let me move. We have a lot of slide. We are still on second or third slide. Are you getting like what I'm trying to explain, right? You are understanding, right?
Yes, Jackie. Yeah, yeah.
Yeah.
We
Now
are.
let me explain this route table. So route table generally basically define how traffic can be sent out, or how like it can communicate with other subnet, how it can communicate with the net gateway. You can define everything into your route table. Now let's consider here I have some route table on my private subnet. So it's 0.0.0.0. So like basically like any IP on this particular private subnet can communicate with a firewall subnet, right? If you see on firewall subnet, like if firewall subnet, if that particular rule is available on firewall subnet, then firewall subnet, here we have written rule. So any IP addresses from this firewall subnet can communicate with the net gateway, right? On public subnet, you can see 0.0.0/0 IGW. It's nothing like from public subnet. Basically, any IP in the public subnet can communicate with the internet gateway, right? So that's these are the rules I have defined. Now we just talk about the data plane. So this is what we have to set up, like by ourselves. We have to design this, like, and we have to manage this, so we have to create VPC, we have to create subnet, we have to create internet gateway, we have to create. If you see on the internet, like you will get a Terraform script. Like you don't have to go and set up everything manually. You can just run the Terraform script. It will spin up EKS for you. Now I will come to uh, control plane, EKS control plane. So basically EKS control plane runs in the AWS managed VPC, and like EKS control plane, like basically it's also AWS managed basically, right? And now EKS control plane want to communicate with this data plane, right? Or data plane, or like how it can do. So whenever you are setting up the EKS cluster, it also install a EKS managed ENI. Like it's nothing, it's an elastic network interface. So EKS can control plane can communicate with data plane via this ENI. So generally it define ENI in multiple availability zone. Generally it will define two ENI, one in like any availability zone. So like for high availability, if one ENI is not working, the other ENI will use to communicate with your data plane. So there's a kubectl ut. So if you want to manage your EKS cluster, you use the kubectl CLI basically. So you can see that, like if you want to set up, or if you want to set up ingress or anything, you use the kubectl. So kubectl communicate with control plane, and control plane communicate with the data plane via EKS manage ENI, elastic network interface. Now somebody asked me question, how we can communicate with a private subnet basically. My application deployed on the HTTP listener, and I want to connect that application. So then comes into picture ingress manage load balancer. So basically you need to set up a ingress load balancer. So you can bring your own ingress load balancer. It can be nginx, it can be alb, anything. You can set up that, and that ingress load balancer, like client can send the traffic to that particular ingress load balancer, and that ingress load balancer can communicate with a private application, the application deployed to the private subnet. So we have something called ingress. We call in Kubernetes world, we call as ingress managed load balancer, right? So this is how the communication happen. When you fire any kubectl command, that goes via AWS control plane, and when client want to communicate with the application which is deployed on the HTTP listener, they can use the ingress managed load balancer. So in this particular EKS, you can bring your own ingress load balancer. You can use nginx, you can use ELB. Any question? This is the complete
Yeah,
architecture of EKS. We will talk about RTF next.
yeah. So when the inbound traffic can be accepted via this ingress, as you say, right? Why can't the
Yes.
outbound? So why should we go on other way which will not get when firewall?
See, have you ever seen like you can send the traffic outside via load balancer?
No, I'm asking.
No, no. Like
This
let
is
me
an
ask,
option of
why
yeah.
why we create a load balancer? Load balancer is generally always to get the inbound request, not for sending the outbound request. If you right,
That makes sense, but maybe I ask this way. So, so whether since Ingress can, can access the private subnet, is there any other option that we have in Kubernetes world that you can send the outbound traffic as well from the private subnet
it's
apart from
it's
Runtime?
it's not about Kubernetes, it's about cloud computing, right? So you setting up the Kubernetes, like it doesn't matter, like what, like it doesn't matter, like how you want to send outbound traffic, it doesn't matter to Kubernetes. In AWS we have only one option, that is the net gateway. If you see Oracle cloud, if you see any cloud, net gateway is used.
Yeah, understood.
Or like how can you send the traffic out from load balancer? I never heard that, right? We cannot send the traffic outside from the load balancer. Load balancer is always exposed for client to send the traffic inside, right? Apart from, on the top, if you want to hide this load balancer, ingress manage load balancer also, on the top of that you can set up external load balancer also with a custom domains. Basically you can do that also. Okay, any other question?
Jackie, just one small question. This Ingress managed load balancer, it is related to AWS or is it a independent load balancer?
It's a Kubernetes based load balancer. Basically you have to
Okay.
create a YAML file, and like you have to define the specification in that YAML file. I will show that YAML file, don't worry.
Okay. Okay.
Okay,
Sure.
I will be walking through that. So
Okay. Okay.
like this is very important, how you need to set up the EKS architecture before like before we get into the runtime fabric. You have any question, like I will ask like any question before I move to runtime fabric manager.
So means in demo we can cover this, the architect, means how we configure, so that.
There is a no demo right now today, right? So it's completely like it's already like demo will take another 1 hour for creating everything, right?
Mhm.
So I will keep one session for demo next month. Okay, so don't
Okay.
worry about that. So we will set up everything, I will show you everything.
Okay, fine.
Okay, so thanks. Like, let me go to the next slide. What is a runtime fabric manager? So runtime fabric manager, it's nothing. It's a container service for deploying, for running, or for managing your MuleSoft application. You can set up runtime fabric on bare metal server, virtual machine. You can set up on self. You can also use the self-managed Kubernetes, and self-managed Kubernetes support GKE, AKS, and EKS basically, right? So apart from that, so there are two management option for runtime fabric manager. So you can use, as I mentioned, self-managed Kubernetes and runtime fabric on the VM, virtual machine, and the bare metal. Right? Let me talk about some responsibility. So, like when you are setting up the RTF on the self-managed Kubernetes, right? What is your responsibility? So MuleSoft will only provide a runtime fabric component, right? And it will only manage like Mule runtimes. Apart from that, it's all your responsibility, like networks, or your worker EKS, worker nodes, networks, net gateway, internet gateway, subnets. That has to be the customer provide. When I say customer provide, like it can sometime it may be like managed by the cloud, managed by the cloud provider. But it will 100% sure it will be not managed by a MuleSoft. So MuleSoft will not going to manage like your application APIs, your nodes, your networks, your infrastructure, your control plane. That will be not managed by MuleSoft. MuleSoft will provide you only runtime fabric component that you can set up on your EKS and Mule runtime. Like so while deploying the application, it can pull the Mule runtime from the MuleSoft Docker registry and set up your application, right? Now it when it comes to RTF on the bare metal server, so MuleSoft will manage a Mule runtime, all the runtime fabric components, and it will also manage the runtime fabric appliance. I will discuss what is this runtime fabric appliance. But you have to in this all case also you have to manage all your storage, hardware disk, virtual machine, and host operating system. RTF on bare metal server or VMs, MuleSoft provide you Kubernetes and the Docker engine. So that is nothing like that. That is completely your runtime fabric appliance. So Kubernetes and the Docker is provided by the MuleSoft. In on self-managed Kubernetes, like you have to use your own Kubernetes and the Docker. So basically, in this, if you are setting up on the EKS, so EKS will provide a Kubernetes and the Docker for running your runtime fabric components or for running your MuleSoft application. Any question on this? Like any question on this customer shared model responsibility?
Jackie, I do have one question. Uh, so when we have to make this decision whether to go for the self-managed Kubernetes or the VMs or the Cloud Hub.
I will come on that. This is
Okay,
too early
okay,
to ask. I will come on
okay,
that.
okay, sure.
Yeah, you will come to know why. I will just give some hint. It's all about hardware basically. Okay,
Okay, okay,
I will come
sure.
on. Yeah. So again, I will going to explain again this diagram. So on, like, I have a RTF on bare metal server VM, RTF on self-managed Kubernetes. So if you see the here, one difference in RTF on bare metal server, you have a runtime fabric appliance, but you don't have a runtime fabric appliance on self-managed Kubernetes, right? That's a one big difference. But like runtime fabric appliance is nothing. It's a Kubernetes and Docker components provided by MuleSoft, and those will be managed by MuleSoft only. In case of EKS RTF, you have a like EKS control plane. The Kubernetes will be provided by the cloud provider basically, right? So that's a one bigger difference between MuleSoft bare metal server and the RTF on the self Kubernetes service. Here you can see what MuleSoft will manage and what the customer will manage. So if you see the dash, whatever above this dash will be managed by a MuleSoft. Whatever below this dash line will be managed by customer. In this case, whatever above the dash line will be managed by MuleSoft, but application doesn't manage by MuleSoft. Make sure like it is your responsibility, right? That underlying Mule runtime and everything will be managed by MuleSoft, but application doesn't manage by MuleSoft. It's up to you, like what kind of application you want, what kind of API you want, how many work replicas you need to deploy API, those kind of thing. And in this case, or EKS will be managed by your a cloud provider or like your KA at Kubernetes specialist basically, or it can be customer managed basically.
So
What?
here in in Jackie, can you just go back to previous slide? Yes, thank you. In RTF on bare metal server, if I want to deploy the control plane inside, so can we do that as well?
No, 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 you
Okay,
cannot do that. Control plane will be always in any point platform.
always okay. Fine.
Jitendra, like I heard, maybe I'm not sure. There's an OpenShift adaptation as well. MuleSoft is considering, right?
Yeah, I heard it was in their roadmap, but I don't have any confirmation about that. But I've seen it's in their roadmap, so they will come. RTF will be also come in the OpenShift. I've seen in their roadmap basically.
Okay, so currently whatever the RTF on bare metals are virtual machine. So whatever the MuleSoft product is having, underlying is having Kubernetes and Docker.
Correct. So there are some feature for runtime fabric on the self-managed Kubernetes. We have ingress controller. We already talk about the ingress controller. So basically, ingress controller allow you to specify like you can use any ingress controller of your choice in case of self-managed Kubernetes. In case of runtime fabric manager on virtual machine of bare metal, ingress controller is provided by MuleSoft, right? No, in this case you can use your own ingress controller. So what are the capability of ingress controller? It perform SSL uploading, SSL tunneling, load balancing, routing, so ingress also can also expose the HTTP or HTTPS route from the outside the cluster to the services within the cluster basically. Then come to the persistent gateway. I'm going to discuss more about the persistent gateway. So basically, if you want to ensure that your object store or VM queues data are persistent, you need to make it the persistent gateway. By default, the persistent gateway is not set up. You need to set up it separately. Okay. And last mile security. So whenever what happened, whenever the request come to your ingress controller on HTTPS, the ingress controller will do the SSL offloading or SSL termination. Then it will send the traffic to the MuleSoft application running in the container over the HTTP. And in runtime fabric manager, there is only one port supported, that is 8081. It doesn't support any other port. Doesn't matter whether on HTTP or HTTPS. So last mile security means whenever the traffic come on ingress controller on HTTPS, it will do the SSL tunneling towards the application. So basically, it will send the traffic to the application on HTTPS only. So it's an end-to-end HTTPS, right? So that is known as the last mile security. We are going to discuss more about that. Just make sure it only support 80 for HTTP as well as HTTPS. So let me talk about a persistent gateway. So what is the persistent gateway? So when you set up a persistent gateway, why we require the persistent gateway? So by default, like there are few options in runtime fabric manager. So in runtime fabric manager, like you can deploy the application on multiple replicas. So when I say multiple replicas, so your two instance of application will run, right? So by default, like if you are selecting more than one replica or application and you want to run those replicas in the cluster mode, so when while deploying, there is a one option enable the application in the cluster mode. You have to select that option. So if you select that option, the data will be shared between both the application. Like if you have object stored data, if you have a vmqs data, those data will be stored across both the application. You got my point, right? The data will be shared across both the application. If you are not keeping application, if you are not deploying the application in the cluster mode, the data will be not shared. Even the application below, the replicas belong to same application, the data will be not shared across the application. The application will create its own object store basically, and this will create inconsistency across the application, right? So whenever you are using object store or vmq, make sure you are always enabling the application in the cluster mode, so you will get a clustering between both the application. But that clustering is not persistent. Once the application crashes or restarted or like redeployed, all your data will be lost, right? So for that case, we go with something called persistent gateway. You need to set up a persistent gateway pod. There's a single line command you need to use, right, for setting up the persistent gateway. That there's a prerequisite for setting up the persistent gateway, that is the SQL database. So right now persistent gateway support only one SQL database, that is the PostgreSQL database. So generally, like you need to set up a PostgreSQL database. Once you set up that, then you can like manage your connection string, great, and then you can set up a persistent gateway on your worker node or within the EKS cluster. Once you have done that, so whenever you deploy the application in the cluster mode, your data will be persist. Even the application restarted or even application like recover from any crashes, or like whenever you redeploy, that your data will be not lost. That will be available in your PostgreSQL database, and that's why we make use of the persistent gateway. Then it comes to the ingress. So client can send a request to the ingress load balancer. Then ingress will send a request to the services. So it's a some abstraction layer. So through that service, the request will go to the proper pod. Pod is nothing. It's a place. It's a container where your application is running right now, right? So in MuleSoft, what is a pod? I will explain. So in MuleSoft, on one pod, you can you can run only one application. The pod contain a Mule runtime and the application, basically like application, right? So it will set up a mule runtime in that pod, and on the top of that mule runtime, it will deploy your MuleSoft application. Each pod have a mule runtime, okay? And it's also one of the good advantage with this runtime fabric. Like your one application can run on mule 4 3.9, one application run on mule 4.3, one application can run on mule 4.1. So you can run a version of mule runtime in the same EKS cluster. That's one of the advantage. Then I will come to last mile security. The client can send a request over https on port 443 to the ingress. Ingress can route this traffic to the mule application on port 8081 on https. So that is known as the last mile security. So getting the request on https till end, it's https. So this is known as the last mile security. Any question on these three concept? No. What?
Jackie, sir, one question I have
Hmm.
about this last mile security. So, can we say that uh, EKS model does not have a shared load balancer model? It always act upon dedicated load balancer only.
Here
Is
there is a
that
no concept of dedicated load balancer.
okay? Okay.
We do dedicated load balancer is the concept of the cloud of, right?
Hmm.
Here we are talking about the ingress. So like Kubernetes doesn't support the dedicated load balancer. We talk about the ingress basically. So
Okay.
dedicated load balancer is completely it's out of like runtime fabric manager.
Got it. Okay.
Now I will be coming to a CPU bursting concept. It's one of the very important concept in the Kubernetes world basically. So what is the CPU bursting? Runtime Fabric manages CPU bursting is using a Kubernetes based CPU bursting technology. With CPU bursting, application running in the pod can consume spare CPU than allocated. So basically what happened like in CPU bursting, so consider you have allocated a zero point 0.1 cores to your application, but the number of requests increases on that particular application, and it require more CPU basically, more CPU space. In that case it can definitely use the available CPU, and that concept is known as the CPU bursting, right? Whenever like I will talk about let me open my notepad, let me remove this. So in MuleSoft, whenever you deploy application on runtime fabric, you have a two parameter, CPU reserved, and there's a other called CPU limit, right? So let's consider I give a CPU reserve equals to zero point 0.1 and CPU reserve also zero point 0.1. So CPU reserve means like the application will 100% get this guaranteed CPU. Okay, your application will always get zero point 0.1 cores basically, right? Here I've defined a CPU limit. In this case, what happened? My CPU reserved equals to CPU limit. So in this case, CPU bursting will not happen. So I will say CPU bursting is disabled, right? This is the first concept. So here CPU bursting will not happen. Like your application will definitely get a zero point 0.1 cores basically, not more than that, right? Apart from that, you have a other scenario. Let's consider I also in zero point 0.1 core, and I am saying you can extend up to zero point 0.7 cores. In this case, if load increase on this particular like on application and it require more CPU, it can extend up to zero point 0.7, but this is not guaranteed.
Jackie, one question here.
Let me complete, let me finish this, let me finish
Yeah.
this. Okay, so this is not guaranteed. If cpu is available, if cpu is available, it extra cpu is free, then it can extend or it can burst up to zero point 0.7 core. So sometime it may possibility like you have assigned zero point 0.7 core, but only like only cpu remaining is 0. Only available cpu is zero point 0.2 cores, like it is not using by other application. So like it can go from zero point 0.1 cores to zero point 0.3, like zero point 0.2 is available, right? So it can burst up to zero point 0.1 because the maximum limit is zero point 0.7, right? So let's consider there might be scenario where like I want more than zero point 0.7 cores. No, because we have defined the limit of zero point 0.7 cores basically, right? So that is the concept of cpu bursting. Let me explain with a diagram. So here I have like the worker node with the I have a CPU free 1.8 cores basically. Here I've defined a MuleSoft app having reserved CPU of zero point 0.2 cores and CPU limit up to zero point 0.7 cores. So application CPU overloaded and can use up to zero point 0.7 cores, not more than that, as CPU limit is zero point 0.7 core. So basically now I have already 1.8 CPU is free basically, but it can extend up to zero point 0.7 cores. So load increases, it has like burst up to zero point 0.7 cores, and now only CPU available is 1.3 cores. Like application overload comes to normal traffic, the CPU will again again come to this particular position basically, right? Here again I will give you one example. So basically like let's consider this particular diagram. So I have container one where my MuleSoft application is running. My reserve CPU is one core basically. The total CPU is two cores basically, and now what you can see, a free CPU is one core, right? And here if you can see the CPU limit defined, that is a 1.8 core basically. So basically in this case what is happening, reserve CPU is one core, CPU limit is 1.8 core, so total out of two cores I 1.8 cores, so only zero point 0.2 core is unallocated basically. Let's consider a container one is overloaded with number of requests and CPU is throttled to 1.3 core. It can throttle up to 1.8 core, but it throttle to only 1.3 core. Even the CPU limit is allocated 1.8 core, as spare CPU is not available to throttle up to 1.8 core. If you see it here, it's supposed to throttle up to 1.8 core, but it it haven't. Why? Because other application is using zero point 0.7 cores basically, and only available is zero point 0.3. So it will extend or it will burst up to 1.3 cores. Is there any question on this? Yeah, Arvind, now you can ask me question.
So Jackie, like they say in RTF, your core size will be in the increments of 0.05, I think, like, or 0.01.
No, you
Is
can
that
define 0 point also. Okay, it start the minimum core you can allocate it in RTF is 0.02 V cores.
okay?
Minimum.
Got it. Thank you. Thank you. That's what
Minimum.
yeah, yeah.
This is
Thank
the
you.
minimum limit you can,
Mhm.
like cloud. I was coming to this, like I have slide for that also. Okay.
Yeah, okay.
So and
Got it.
in
Got it.
cloud up it's 0 point V cores, 0 point V cores, 1 V
Yeah,
cores
one
basically.
week course. Yeah, that is
Yeah.
correct. Thank you.
Okay.
Uh, Jitendra, I just have a question. This is back to the persistent gateway, not as a single question. So when I use the persistent gateway, right, from the Runtime fabric, so you mean to say I can save the application data in persistent gateway in terms of the object store? Is that my
See,
understanding
in
right?
see in clustering what happen, like so generally what is the object store? Object store contain the data which is key value pairs basically, right? And like I want to persist those data, so that what happens, so it will create a database in the PostgreSQL, and it will store all those data in that database.
Yeah. So it's ideally persisting the object store in terms of basically
Can you
persistent
just
gateway.
like I'm not getting your question, like you are not enough.
Yeah, so maybe I will rephrase this question this way. So, and as per my understanding, persistent gateway is used for persisting the object store that is being
It's
implemented in
not
the
about
any
persistent object store. It can be vmqs and any data you want to persist, like any clustered data, right? It will get persistent. It will be like it will be mostly object store or vmq data, right? Yeah, go on.
uh, maybe can you explain that once again? Maybe I'm not clear there.
It's a simple, right? So basically, like you want to like when you are deploying, I will explain in next slide. I have a diagram for that. Okay, let me just I will explain.
Sure.
So I have other slide for that also. So what are the benefits of runtime fabric on the self-managed Kubernetes? So basically, it will reduce the infrastructure cost. Like in case of bare metal and VM, like you need to have a you need to provide the upfront servers, right? So like you have to manage your own control node, or you have to also define your worker node. Like you need to allocate it like RAM, you need to allocate it the proper storage and everything you have to do it upfront basically, right? In self managed, like it's not like that. It depends, like it automatically your control plane is automatically scale depending on number of requests, and it also like downscale depending on your number of requests basically. So you don't have to worry about the hardware, you just have to worry about the worker node hardware basically. And even in case like you can create a two or three worker, and you can put those worker node in your auto scaling group. In that case what will happen, so depending on the number of depending on like number, it will reduce the number of server or it will increase the number of server basically. So those kind of things can be done automatically. Like auto scaling doesn't support it on runtime fabric virtual machine and bare metal, but it is supported here in ES RTF. Okay. So more visibility to operation teams for managed Kubernetes environment. Self-managed Kubernetes service provider like AWS Azure offer auto scaling, automatic Kubernetes upgrade and component. So in this case, like you don't have to worry about the control plane Kubernetes upgradation, like patching and all those things. That will be automatically managed. Kubernetes controller manages by the self-managed Kubernetes service provider like AWS and Azure. So runtime in runtime fabric manager, the one of the biggest challenge to set like manage a big hardware, like a big infrastructure. You have to manage your control plane, everything. Here it also giving the flexibility of choosing your ingress load balancer. You can choose your own ingress load balancer. So generally the famous one is NGINX. So generally we always use the NGINX, but you can use any other also. Like you can check the Kubernetes document, what other load balancer we can use for the ingress. But I always use the NGINX basically. Okay. Now I will come to before I go to, I want to show one diagram. Where was that diagram? I missed it. Let me just let me copy the diagram. I will show you basically. Just give me a second. I have that diagram. I don't know where. I want to show that to Raghu, right? Regarding that, I think I have deleted that slide. Let me find that diagram. Hopefully, I will have it. Yeah, I got the diagram. Good. I think this diagram. Unshare the screen, right? Let me share it again. Can you see my screen?
Yes, Jackie.
Okay, good. This is my RTF architecture. So like somebody asked me about auto discovery, somebody asked me about persistent gateway. This diagram should clear a lot of concept. So okay, so now you have a EKS control plane and one is RTF control plane. RTF control plane is for runtime fabric and EKS control plane for your EKS. So EKS control plane will be managed by your cloud provider. RTF control plane will be managed by your MuleSoft. Is this clear? So we have a two control plane. Now we have a two kind of clustering. One is at a infra level. So like you have a multiple nodes, that is the EC2 instance. So those are clustered basically. So that is known as the infra level cluster. Then there is a application level clustering. So when you are deploying your replicas or application in the cluster mode, that is known as the clustering. Now Raghu, I will come to your question. So basically F3 and Mule F3, like I have a two replicas of same application, and that application is using VM and OA, like object store basically, right, for communication. And I want to share this VM and object store across both the applications. Done, I have deployed the application in the cluster mode, so that so I can do the data sharing basically. So that is known as a Hazelcast clustering, right? So I have deployed the application in my cluster mode, right? I've done that. Now what happening, like later I have realized, like whenever I'm doing the restart of application or anything, like right, whenever I'm doing any restart of the application, what is happening, my data is losing from VM and the object store basically. It get loose, right? I'm losing the data during the redeployment or application restart or application crash, it get restarted basically. I'm losing this VM and object store data, right? So I need to provide some solution to my customer how I can persist those data, like even my application is restarting or during the redeployment time, I do not lose the data. It can be persisted. Then I come up with a concept called a persistent gateway. So this is, I think, concept introduced by MuleSoft last year itself. I don't know like exact date. So what I can do, so for persistent gateway I required a JDBC database, and right now it does just support a PostgreSQL. I need to set up that database and set up a persistent gateway port. There's a single line command we have to just execute on the Kubernetes. Once you done that, it will persistent gateway. Now whenever, whenever your application 3 or mule app 3 will restart it, or it recover from any crashes, your data will be not lost from the object store and this VM queue. You can get those data, and the both application share the same object store and the VM basically. Is this answer your question, Raghu?
Yes, yeah, yeah, yes.
Got it. I told you, like I will explain everything, don't worry. Okay. So now other thing. So as I mentioned, like you can run the multiple Mule runtime, multiple version of Mule runtime on the same EKS cluster. So here you can, like, generally whenever you deploy the application, you select what version of Mule you want. So what will happen, that during the deployment, it will pull a Mule runtime from the Docker registry, and it will set up a pod. In that pod, it will set up this Mule runtime. On that Mule runtime, it will set up the Mule application, right? So right now this is the MuleSoft owned registry. I heard in future, like they like mm, there will be concept, and customer can also manage this mule runtime, and like, should able to pull the mule runtime from the customer network also. It will reduce some deployment time, latency time basically, but I'm not sure whether when it will become. I heard about that basically. Okay. Whenever I deploy the application within the any node, they want to communicate with the API manager, they can use the API auto discovery or API proxy concept basically. They can make use of API auto discovery or API proxy, right? So like, once we done that, once the API proxy or API auto discovery enabled, you can apply any policies, any out of box policy, any custom policy. You can see the matrices, like you can do the complete API lifecycle management, like you can completely make use of the API manager capability. Is this clear? RTF architecture. And apart from that, we have some other container, am log forwarder. So basically this container or sorry, this pod will be available in each. So for forwarding logs to the some external system, basically maybe CloudWatch, maybe Splunk, maybe any you can define those configuration.
One question, maybe this relating this particular architecture with the cloud computing. So the MuleSoft will be installing the Mule runtime in each of the nodes, part of the EKS, and the control plane.
Your voice is not clear, like is that problem with me or like everyone? His voice is like bit not clear, right?
Am I audible?
Yeah, now you're audible.
Okay, let me ask the question again. So on the EKS control plane, we have multiple node, and the Mule runtime will be deployed by the MuleSoft. And the question is, from the Mule runtime, how the connection made to the Mule control plane or API manager, which is running somewhere else. Because as you said, we cross over multiple subnets here being private.
We
So
talk about net gateway, right? So
so
via
using that.
net gateway it will make the connection to the anypoint platform, na?
Okay. So okay.
And like there are some kind of URLs, right? I will show you on the, like, that needs to be allowed in your firewall, right? No, so MuleSoft provide the like description about that. Let me find out right now. Just give me a second. RTF, I cannot see RTF. Let me do RTF. There is some kind of firewall you need to open, like directly it will not allow. Basically you are right, we need to open some kind of. So MuleSoft provide the list of rules on their documentation, what are the rules needs to be open basically. I cannot see where the, I know, like there's a list of rules available on MuleSoft site, you can use that, I'm just searching for that. Yeah, I think it should be right. Let me check. I'm just showing there is some prerequisite. Like yeah, this is the site. So here you can see, like, so I think I just a minute. Yeah, these are the some rules you need to open. Everything on mention. What are the URL that you need to open? Everything is mentioned on that site. You need to open all those rules.
Yeah, understood. One final question from me. So when we use this API auto discovery, right? So each container will have all the policies and gateway usually running on that, right,
No,
along with the application.
definitely, like, it will be like, it depend like what, it will not have all policy. Whatever policy you are applied, those policies.
Yeah, yeah, I mean specific to the application, whatever I applied to the API manager.
Yeah,
So,
that will be.
so when I use the auto discovery, so it individually running it as an entity. So ideally there will not be any technical connection between the container and the API manager when there is transactions happening, because all the policy
There
enforcement,
will be,
everything.
there will be. It sends some metrics and all, definitely connection.
Because the
It
gateway
send
gateway itself.
no, but it will definitely send the data. If you see for each API instance, you can see metrics and everything, right? It will definitely have a connection to send the metadata to the API
Yeah,
manager.
that is why for monitoring purposes I understand. But with respect to the the API policy enforcement, so all these things will happen inside the container itself, not on the API manager.
Yeah,
Right.
true. Okay. So now also, like, how to implement a TLS on EKS, basically how does it happen? So generally, like, client will send a request to external load balancer. From external it can come to the ingress load balancer. So like ingress load balancer will send the traffic on the HTTPS to application 1 and application 2. This is last mile security. And also you can configure the TLS basically. So in your ingress YAML file, you can define a TLS, and like you need to define host. You need to define like, what is the host and its secret. So basically you can set up your certificates in your Kubernetes secret. So basically you can use this particular command kubectl create secret TLS RTF. Like this is the command where you have to tell I want to create a TLS secret, and you have to private key and the public key, and that will store on your Kubernetes secret basically, right? Once it done that, then in your like ingress YAML file, you need to define this particular configuration basically, and that will enable a TLS basically, right? A TLS, because generally if you are not installing the certificate by default, it will set up a fake certificate. So like whenever you try to browse your URL, so it will not do the SSL and it will give some security warnings basically. So that is like, it is always recommended to set up CA sign certificates basically. So for setting up certificate, first you need to create the secret, and that secret needs to be point into the ingress.yaml file using this particular syntax. Okay, and then you have to apply ingress file again, and whatever previously application deployed before enabling the TLS, you need to restart all the application to like, to adapt a new ingress controller configuration. More concept. So basically like when you're deploying the application, let me show you one screenshot. Yeah, here you can see when you deploy the application, there is a one concept: enforce the deploying replicas across the node. What does this mean? So by default, let's consider I am deploying the application. I've selected I want to deploy the application on two replicas. It means like it will definitely deploy the two replicas or two instance of your application, but it doesn't mean like it will deploy two replicas on separate node. There might be possibility the two replicas can be deployed on the same node also, right? To avoid that, you can ensure that like if you want to deploy replicas on multiple nodes, like separate node, you can ensure that this property has been checked. Enforce deploying the replicas, and this property will be only enabled when you are selecting the multiple replicas. Is this answer your question? I also talk about the reserve CPU and the CPU limit. You can define that also. Like this is used for CPU bursting kind of thing, right? So default, when you are deploying your application on multiple replicas, it will not guaranteed whether those two replica will be deployed to the separate node or to the same node. In this case, you can always ensure, you can always enable this particular property and force deploying replicas. You have also have a run in the runtime cluster mode, right? So if you want to run the application in cluster mode, you can use this particular option. Okay, let me talk about some more interesting concept basically. Like this is something related to SNet basically, an IP address netting, and like so I will give one scenario. I have an application running in my private mode, and that application has to connect with some application or some web service where the IP whitelisting is required for source application. Like ip ip whitelisting will be required for my pod basically. So generally what happen, so let me explain few more concept. So you have a vpc, you have a subnet. Within subnet you have a pod. So you have defined vpc of some range 10.0, like 10.0.1.0/16, and here you have given the subnet of range 10.0.1.0.24. Now, whenever you deploy the pod, each pod will get an individual IP address. So from this particular, so let's consider this pod got IP address of 1.34, right? So each pod will get an individual IP address basically. So let me maximize this. Here my requirement is that like my pod want to communicate with some external service where IP whitelisting is required, right? So I cannot whitelist this private IP address, and this pod IP address keep on changing. This is dynamic. While redeploying, while restart, this IP address is keep on changing. And even this is the private IP address. Like generally when we communicate outside, we communicate via public IP address. Is this right? Okay, so generally I have a two scenarios. So let's consider I created my EKS node in the public subnet. Let's forget about like private and right now. So I've created my EKS node in the public subnet. I set up my EKS cluster in the public subnet. My worker node is in the public subnet. I deployed one application. So like if you see, the internet gateway is associated with this particular and now I've deployed one application. That application like got deployed on, like, it create a pod, and that pod gets some private IP address. You can see the 10.0.1.22. So whenever like I will create a public worker node, it will get a public IP address basically. And it will get a public IP address and one private IP address. So generally when we communicate it outside to the external service, it is used the public. But right now my worker node is not communicating with the external services. It is the pod who want to communicate with the external service, right? But pod doesn't get any public IP address, it will get only private IP address. So how it will be communicate? So what will happen when pod want to communicate with this? So there will be SNet, there will be source network address translation. My pod IP address will get converted into the worker node IP address. Worker node public, can you please go on mute? So worker node public IP address, and that particular IP address will be whitelisted on the external services, like 54.98. This is my worker node IP address basically. And who does that translation? CNI. So CNI is nothing, it's plugin which convert pod IP address into your worker node IP address. But this is the case in the public subnet. But we will never deploy our worker node in the public subnet. We will always deploy our worker node in the private subnet, right? So here comes to a second picture where like I have a worker node in the private subnet, and it will doesn't get a public IP, it will get one primary IP address. Now I have deployed application in the pod that got some pod IP address, that is 10.0.1.22. So generally node IP address doesn't changes. Okay, pod IP address can change while redeployment restart or no, when it try to recover from recache. So in that case what will happen, we will have a public subnet where we have a net gateway and public subnet associated with the internet gateway. So now the pod will directly send the traffic to the net gateway. Then now the IP address transfer on here. So like pod IP address will be converted into the public IP address of the net gateway, and now net gateway IP address will be whitelisted on external service, so it can communicate with the external service. Whenever a response comes, the external service will be also respond on like a net gateway IP address, and net gateway will respond, send response back to the pod. So CNI is some protocol that perform SNet. SNet is nothing, source network address translation. So these are some protocol, and this is some networking concept basically. Okay, there are some runtime fabric manager on self-managed Kubernetes also comes with some limitation. So like you can have up to maximum 30 worker nodes on one EKS cluster. So it should be always VM based nodes are required. It should be a virtual machine, EC2 instance in case of EKS. Fargate is not supported. So replicas per application, you can create up to 8 replicas per application. It is recommended to deploy like 40 replicas on per node, not more than that. So you can associate a single runtime fabric up to 100 environments in any business group, and you can up to like you can assign a runtime fabric manager in 50 business group. And object stored persistent, you can use the object, like you need separately a persistent gateway, and persistent gateway only support the PostgreSQL database. And this is my final EKS RTF architecture will look like basically. So let me so I have a if you see, I have a two environment. One is non-prod environment. Basically I have a like some customer data center which is located outside the AWS. You can see that, right? And like I have a anypoint platform basically which is also outside the AWS. So now it's the same, like I have set up some like private subnet, firewall subnet, public subnet in both the environment. Then I have a internet gateway, net gateway, route table is associated with each and every subnet, right? And now I want to connect from this particular, and they are in the separate. And if you can see the elastic Kubernetes service control plane is in some separate it's a AWS managed VPC, and they will communicate EKS manage ENI, which we have discussed, right? We have discussed all those things. Now what we want to do, we want to connect to the customer data center. We can create a VPN connection between via transit gateway, or even you can directly VPN connection without transit gateway also. And you can use the AWS direct connect to the customer data center. And for like we have a anypoint platform. This control plane is for the RTF, for managing your runtime fabric manager, and you can like apply API manager using this API auto discovery and the API proxy. It's just check. And let me compare. So we have some comparison: RTF on bare metal and virtual machine, RTF on self managed. Kubernetes, it's a MuleSoft provided. RTF on self managed, we have to bring our own Kubernetes. Basically, it can be EKS, AKS. Ingress included, not included in self managed. Op Center URI. So this is UI to manage your Kubernetes. It's available on bare metal. It's MuleSoft provided, but not included in the self managed. You can use the respective cloud provider portal to manage your Kubernetes. External log format by default it is available. It's included on bare metal. It's not included on self EKS. You can use any cloud provider forwarder. Basically, it can be CloudWatch, CloudTrail, depending what kind of cloud provider you are using. Capacitor alerts. So it's capacitor alerts. It's available on bare metal server, not available on the self-managed Kubernetes. Installation options, basically, MuleSoft provide the scripts like Terraform or like Azure template scripts. Whereas RTF on self-managed EKS, you can set up on EKS, EKS, GKE. So RTF component and services included in both. And Docker, here Docker is MuleSoft provided, and here Docker, like customer has to bring own Docker. Basically, when I say customer, it will be a cloud provider. Anypoint security is supported on bare metal virtual machine, doesn't support it on RTF self-managed EKS. So basically, anypoint security is nothing. It's a age security for your runtime fabric basically. But in self-managed, you can use the cloud provider of web application, firewall, whatever, like whatever security you want to use, make use of that. Persistent gateway supported in both. Last mile security supported in both. Upgrading runtime fabric. So here, like on bare metal, you have to upgrade RTF component, RTF CTF command line and node configuration. On this particular, like MuleSoft will only upgrade a runtime fabric component and the RTF command line utility. Here node type support bare metal servers or virtual machine. Here like like VM based nodes are supported. Fargate is not supported. In case of AWS, it support EC2 instance. Maximum number of control node on self managed on VM is 5. On self managed control, like as I mentioned, we don't have to worry about that part. That automatically will taken care by the cloud provider. Maximum number of control node we have talked. It can be 16 on bare metal and it can be 30 on self Kubernetes. Replicas per application, it's same on both. Replicas per worker node, it's same on both, right? Associated environment per 50, and here it's 100. Business group 50-50. Okay, and object store persistent, it's supported. Tokenization service, it's supported by both. Okay, now let me come to some benefit. As we discussed, it reduces the infrastructure cost. Like you don't have to define the infrastructure upfront. You can definitely make use of and those kind of thing basically, right? Like it will reduce the operational activities, like so apart from that, so Kubernetes control plane is completely controlled by a cloud provider like AWS and Azure. Flexibility of choosing our own ingress load balancer and preferred Linux based operating system in case of self managed Kubernetes. So isolation of between the application by running a separate mule runtime per application. As I mentioned, each application is isolated with each other. Ability to run the multiple mule runtime on the same set of resources. On same EKS cluster, you can run the multiple mule runtime on mule runtime version basically. Cheaper to run mule application for longer term compared to cloud hub, as apps can be deployed with a low of 0.02 cores, and cloud hub is 0.1 vcore minimum. Application deployed on runtime fabric can be managed by any point runtime manager, scaling the application across the multiple replicas with zero downtime. You can just without any downtime. And so deployment is also zero downtime basically. It also like have features like intelligent healing or automated application failover in case some replicas is not working well. They are unhealthy. So like RTF will automatically try to recover those replicas and make them healthy basically, or try to create a new replica and remove that particular unhealthy instance. Yeah, that's all about RTF and EKS. I hope like I clear a lot of doubts. Yeah, I know like this is not a easy session. It's a bit complex. Any question? Hello, can you hear me?
Yeah,
Yes,
Jackie,
yes,
we
Jackie,
can,
we
we
can.
can, we can get.
So
Yeah.
what? Let me go to next slide. Any question? Nominate yourself for the next meetup speaker and suggest the topic as well. And like what's next? Like you can join a Surat MuleSoft meetup community. You can contact MuleSoft, for any improvement of the program. The next session is coming on, I think, 11th June, implementing and understanding the saga pattern. Then 24th June. Then we have a 9th July. Yeah, now it's a quiz time. Thank you. Any question? No question?
No, Jitendra.
Anybody
मैंने
have
बोला
any
ना,
question?
मैंने बोला ना, तूने मैजिक कर दिया.
Arey. Yeah, I try to explain, like, whatever knowledge I have, I try to explain that. I know it's not an easy topic to explain also,
Correct. That is true.
but still I took that. Uh, I thought like I should share some knowledge on, like, my experience on EKS. Like recently I've done few setups of this EKS RTF, and I just want to just share that knowledge. That's it.
It was a wonderful session, Jitendra. Actually, so
Yeah,
I saw.
thank you. So Nitish, you are in the call. Hello, Nitish. I think Nitish is sleeping.
Yeah.
Nitish slept half an hour before, I guess.
Let me call him. Where is gone? So
Nitish
there
got
will.
overwhelmed.
So guys, like, there will be content published on EKS RTF by next week. So this will contain all the information what we have discussed, maybe more than that, like, so I will share that later over the LinkedIn. So Nitish is joining. He's already in the call. Like he have some issue. Gajanan, like I don't know about the history why 8081. Okay, so it's a MuleSoft. Like I don't know why they only.
Hey, easy to remember, yeah. Easy to remember. Just take it. Yeah. I mean, like, it's like this. I mean, like, 8081, 80 is supported by internet. So basically, that's the reason they added 8081. I mean, to make it unique. And then that's what they went with. I mean, that's it. There is no rocket science there. Nothing to explain.
Yeah, and never mentioned like why 8081. No reason behind that. See, I will